Let's start, guys. Methods of preparation of haloalkanes. From alkanes, free radical halogenation. CH4 plus Cl2, UV hash CH3 Cl, Cl2, CH2 Cl2, Cl2 CH3 Cl2, CCl4 gives reactivity of hydrogen is benzylic, alkylic, tertiary, secondary, primary, methyl, and aryl. Benzylic, allylic, tertiary, secondary, primary, vinylate, and alkyl. Benzyl, alkylic, tertiary, and from alkenes, electrophilic addition CH2 plus HCl gives CH3 CH2Cl. Order of reactivity of halogenation acid is CHI, HBr, HCl. Mechanical rule is the above reaction follows manual rule. According to this rule, the halogenation part, more negative of the hydrogen halide, attaches to the double bond carbon, which has best number of hydrogen atoms attached to it. The above reaction follows Markov rule. According to this rule, the halogenation part of the hydrogen halide attaches to the double bond carbon, which has least number of hydrogen atoms attached to it. From alcohols, reaction with phosphorus halide with PCl5C2H5OH plus PCl5C2H5Cl plus POCl3 gives plus HCl. With PCl2 gives 3C2H5OH plus PCl3 3C2H5Cl H3PO3. With SOCl2 with chloridazine process C2H5OH SOCl2 pyridine gives SO2 CHHC2H5Cl. This is the best method for preparation of alkyl chloride since the other two products SO2 HCl being gases leave the reaction mixture. Being gases leave the reaction mixtures. Reaction with halogen acid C2H5OH plus HCl anhydrous ZnCl2 gives C2H5Cl plus H2O. C2H5OH plus HCl on anhydrous ZnCl2 gives C2H5Cl plus H2O gives C2H5 plus Cl2. C2H5OH plus HCl anhydrous ZnCl2 C2H5OH plus H2O. Schwarz reaction, halide exchange, 2C2H5Cl, 2C2H5Cl, chloroethane plus Hg2F2 gives chloroethane plus Hg2Cl2. Chloroethane plus Hg2F2 gives fluoroethane plus Hg2Cl2. Finkelstein reaction C2H5Br plus NaI gives acetone C2H5I plus NaBr. By Hunsker reaction CH3COOAg plus Br2 gives CCl4CH3Br. CO2 gives plus HgBr. Primary haloalkanes. These haloalkanes are those in which C atom bonded to halogen atom is bonded to one or more alkyl group. These haloalkanes are those in which C atoms bonded to halogen atom is bonded to one or more alkyl group. Is bonded to one or more alkyl group. Some of the lower haloalkanes are gases CS3Cl, CS3Br, C2H5Cl, C2H5Br. Primary haloalkanes are those in which C atom bonded to halogen atom is bonded to one or more alkyl groups. Secondary haloalkanes are those which are C atom bonded to two alkyl group. Tertiary is C atom is bonded to three alkyl group. Physical properties of haloalkane. Physical state. Some of the lower haloalkanes are gases like CH3Cl, CS3Br, C2H5Cl, C2H5Br. All other are sweet smelling, oily liquid. Higher members are solid, alkyl halides are colorless. When pure bromides and iodides develop color when exposed to light. Higher members are solid, alkyl halides are colorless. When pure bromides and iodides develop color when exposed to light. Many volatile haloalkanes are sweet smell. Melting and boiling point. The carbon halogen bond in case of alkyl halides is polar in nature due to the electronegativity difference between carbon and halogen due to their polar nature. The carbon halogen bond in case of alkyl halide is polar. The carbon halogen bond in case of alkyl halide is polar in nature due to the electron negativity difference. Due to the electron negativity difference. Due to the electron negativity in the carbon halogen bond in case of alkyl halide is polar in nature due to the electronegativity difference between carbon and halogen due to their polar nature. The boiling point of alkyl halide are much higher than those of the corresponding alkanes. This is because of the strong dipole interaction between the molecule of alkyl halide. The boiling point of chlorinated derivatives of methane increases with number of chlorine atoms. The boiling point of chlorinated derivatives of methane increases with number of chlorine atom. This is because of increase in van der Waals forces. That's why CH3 F2 boils at high temperature then CH3CHF. Solubility. Haloalkenes are insoluble in water but are soluble in organic solvent. Haloalkenes are insoluble in water but are soluble in organic solvent. Chemical properties of haloarenes. Nucleophilic substitution. Chemical properties of haloarenes. Nucleophilic substitution reaction, which gives bromoethane plus KOH gives alcohol plus KBr. Bromoethane plus KOH gives C2HBr plus KBr. Substitution of chloride of bromide by iodine. Formation of alkyl iodide. C2H5Cl plus NaI acetone gives C2H5I plus NaCl. Substitution of halogen by cyano group gives C2H5Br bromomethane plus KCN, which will give C2H5CN plus KBr. C2H5CN plus KBr. C2H5Br bromomethane plus KCN gives propane nitride plus KBr. Propane nitride C2H5CN plus KBr. Substitution mechanism by cyano group. Formation of alkyl cyanide C2H5Br plus KCN gives C2H5CN plus KBr. Mendel's reduction C2H5C n plus 2H2Ni gives C3H7NH2. C3H7NH2. Complete hydrolysis. CS3 gives Cn plus 2H2O. Dilute acid, dilute alkali. CS3COOH. Substitution of halogen by isocyanide group. Formation of alkyl isocyanide. C2H5Br plus AgCN. C2H5Br plus AgCN. C2H5Br plus AgCN. C2H5Br plus AgCN will give C2H5 C plus AgBr Substitution of halogen by nitro group. Formation of nitroalkanes. C2H5Br ethyl bromide plus AgNO2 gives nitroethane plus AgBr. Nitroethane plus AgBr. Nitroethane plus AgBr. Reaction with metals. Reaction with magnesium. Formation of Grignard reagent. C2H5Br plus Mg. Bromomethane plus Mg will give diether. On diether it will give ethyl magnesium bromide. Bromomethane with Mg will give ethyl magnesium bromide. Bromomethane with Mg on diether will give ethyl magnesium bromide. Ethyl magnesium bromide. Ethyl magnesium bromide. Ethyl magnesium bromide. Bromomethane plus Mg on diether will give ethyl magnesium bromide. Bromomethane on M plus Mg will give ethyl magnesium bromide on diether. Reaction with sodium. Woods reaction. CS3I plus 2NaI plus ICS3 methyl iodide on ether will give ethane. Methyl iodide with ether will give ethane. Trichloromethane. Reaction with silver powder. CHCl3 plus Ag plus CHCl3 on heat will give Hc acetyl CH HgCl. Carbylamine reaction CS3NH2 plus CHCl3 plus 3KOH on CS3 and will give 3H2O plus 3KCl. 3H2O plus 3KCl. 3H2O plus 3KCl dimer reaction C6H5OH plus CHCl3 NaOH on 340K will give benzene on OH plus COH will give 3NaCl plus 2H2O. 3NaCl with 2H2O. 3NaCl with 2H2O. 3NaCl with 2H2O. Iodoform reaction. Triiodomethane. C2H5OH 4I2 plus 6NaOH. CHI3 HCONA plus 5NaI gives 5H2O. Gives 5H2O. C2H5OH plus 4I2 plus 6NaOH will give CHI3 plus HCONA plus HCOONA. Iodoform CHI3 iodoform. Freons. The chlorofluorocompound CFCs of methane and ethane are collectively known as freons. These are extremely stable, non-toxic, non-corrosive, unreactive and easily liquefiable gas. Freons are prepared by treating chlorinated alkanes with hydrofluoric acid in the presence of antimony from -12 and is one of the most common freons in industrial use. Freons, when used as refrigerants and escape to the lower atmosphere where they don't decompose due to their general, but in the upper atmosphere they absorb UV radiation, from the sun. They decompose on decomposition. CCl bond of a CFC cleaves to produce chlorine radical that reacts with ozone to form ClO. The conversion of ozone to O2 basically means the destruction of ozone in stratosphere, and this phenomenon is called ozone depletion. Haloalines. Method of preparation of haloalines. By direct halogenation, nuclear halogenation, Lewis acid act as catalyst and carry the halogenation to the benzene and aromatic hydrocarbon and hence called halogen carriers. Lewis acid act as catalyst. It act as catalyst and carry the halogen to the benzene and aromatic hydrocarbon. Lewis acid act as catalyst and carry the halogenation to the benzene and aromatic hydrocarbon. Benzene and aromatic hydrocarbon. Benzene and aromatic hydrocarbon. The function of halogen carrier FeCl3 or FeBr3 is to generate Cl minus or Br plus in the reaction which attacks the benzene and other hydrocarbon to form product. The reaction is called electrophilic substitution reaction. 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 Strong diazonium salt pairs Zeeman reaction N2 plus Cl minus plus HBF4 minus HCl will give N2 plus BF4 minus 1F plus BF3 plus N2. Benzene sodium plus tetrafluorobenzene and lean plus HO.NO plus HCl will give on heating with 273 minus 278 K will give benzene N2 plus Cl minus plus 2H2O. Sandwich reaction will give N2 plus Cl minus Cu HCl will give Cl plus NO. Catamines reaction N2 plus Cl minus will give CuCl with HCl on benzene Cl plus N2 plus N from silver salt of aromatic acid, silver benzate plus Br2 with reflux when will give bromobenzene plus CO2 plus AgBr. AgBr. Physical properties of haloarenes. Physical properties of haloarenes. Physical properties of haloarenes. Physical state. Haloarenes are usually colorless, liquid or crystalline solid. Chlorobenzene is a colorless, pleasant smelling liquid. Melting and boiling point. Melting and boiling point of haloarenes increases with the increase in size of aryl group. Increases with increase in size of aryl group. Increases with increase in size of aryl group. Melting and boiling point of haloarenes increases with the increase in size of aryl group. Chlorobenzene boils at 405 K. Bromochlorofluoroarene. 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 Solubility. Haloarenes are insoluble in water. They are insoluble in water. They are insoluble in water. It is probably due to their inability to form hydrogen bonds with water. However, they are quite soluble in organic solvent of low polarity such as benzene, etc. Reaction of haloarenes, electrophilic substitution reaction. Electrophilic substitution reaction. Electrophilic substitution reaction. Halogenation Cl plus Cl2 on anhydrase with FeCl3 will give 1,1-dichlorobenzene and 1,4-dichlorobenzene, which will give minor and major both. Hydration will give Cl plus H and ONO2 H2SO4 Cl NO2 and ClNO2, 2H2O, 2H2O, 2H2O. Substitution by amino groups to form aniline, substitution to form aniline, substitution to form aniline, substitution to form aniline, substitution to form aniline. Reduction formation of hydrocarbons, 2Cl plus 2H, NiAl, NaOH or NaHg alcohol plus 2HCl will give benzene trichromate. It will replacement by hydroxyl group dose process will give benzene on Cl plus NaOH 623K 300 atm ONA 300 atm on ONA dilute dot HCl will give NaCl OH phenol benzene with Cl plus NaOH on 623K 300 atm on benzene ONA will give dilute HCl NaCl on phenol OH. Reduction formation of hydrocarbons miscellaneous reaction benzene to benzene Cl plus 2H on with NiAl NaOH or NaHg alcohol will give benzene plus 2HCl will give benzene plus 2HCl will give benzene plus 2HCl will give benzene plus 2HCl. Woods-British reaction chlorobenzene chlorobenzene plus 2Na plus chloromethane 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 on ether will give ethylene plus 2NaCl. Sand-West reaction chloroarenes and chlororenes N2 plus Cl minus chlorobenzene CuHCl will give Cl plus N2 will give chlorobenzene plus N2. Haloarenes are usually colorless liquid or crystalline solid. Chlorobenzene is a colorless, pleasant smelling liquid. It is usually colorless liquid. It is usually colorless liquid or crystalline solid. Chlorobenzene is a colorless, pleasant smelling liquid. Melting and boiling point of haloarenes increases with the increase in size of aryl group. It is like bromochloro, fluoro, and arene. Bromochlorofluoroarene. Bromochlorofluoro and arene. Bromochlorofluoroarene. 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 Solubility. Haloarenes are insoluble in water. It is probability due to their inability to form hydrogen bonds with water. However, they are quite soluble in organic solvent of low polarity such as benzene, etc. Such as benzene, etc. Haloarenes are insoluble in water. It is probability due to their inability from hydrogen bonds with water. However, they are quite soluble inorganic solvent of low polarity such as benzene, etc. Halogenation. Chlorobenzene plus Cl2 with anhydrous FeCl3 on benzene Cl and 1,4 dichlorobenzene plus 2HCl plus 2HCl. Nitration. Cl plus HONO2 will give H2SO4 plus ClNO2 and Cl2H2O. Nucleophilic substitution reaction. Substitution by amino group to form only 2Cl plus 2NH3 on 475 60 ATM. 475 60 ATM will give 2 benzene NH2 2CO2 Cl2 plus H2O replacement by hydroxyl group. Dose process. Chlorobenzene plus NaOH will give on 623 K 300 atm will give sodium benzene plus will give dilute dot HCl NaCl dilute dot HCl NaCl dilute dot HCl NaCl OH phenol Mischelius reaction reduction formation of hydrocarbons 2 benzene Ca plus 2H Al NaOH or NaHG alcohol 2HCl Wurtz-Fittig reaction Cl plus 2Na chloromethane ether toluene plus 2NaCl toluene plus 2NaCl toluene plus 2NaCl toluene plus 2NaCl. Biomolecules carbohydrate. It is divided in three parts: monosaccharide, oligosaccharide, polysaccharide. Under monosaccharide, it's aldose, ketose. Aldose is of glucose, C6H12O6, and ketose is of fructose, C6H12O6. C6H12O6 oligosaccharide, di, and tetra sucrose, refined as di, and tetra sucrose, raffinose, stachyose, C12H22O11, C18H32, C18H32 O16, C24, H42, O21. Polysaccharide is of starch and cellulose, example C6, H12, O5, and N. Monosaccharide, oligo, monosaccharide, oligosaccharide, polysaccharide. Monosaccharide, oligosaccharide, and polysaccharide. Monosaccharide is of two types: aldose and sucrose. Aldose and sucrose. Aldose and sucrose. Oligosaccharide is of three types: di, and tetra. Di, and tetra. Polysaccharide is of again two types: starch and cellulose. Starch and cellulose. Classification into sugar and non-sugar carbs. It is of two types: sugar and non-sugar. Sugars are sweet, so crystalline, solid. They are sweet, 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 crystalline, solid. Sugar, they are sweet, crystalline, solid. Non-sugar, these are tasteless, solid. They are sweet, crystalline, solid. And non-sugar are tasteless, solid. They are soluble in water, whereas non-sugar is insoluble in water. They are soluble in water, whereas non-sugar is insoluble in water. Example, glucose plus fructose. Example, glucose, fructose, sugar. Example, starch and cellulose, non-sugar. Reducing sugar and non-reducing sugar. Reducing sugar. Alpha hydroxyl aldehyde and ketone reducing failing solution and tolerance reagent. Non-reducing solution cannot reduce failing and tolerant reagent. Do not contain alpha hydroxyl aldehyde or ketone. Monosaccharide. Carbohydrate is of three types: monosaccharide, oligosaccharide, and polysaccharide. Under monosaccharide, it is of two types: aldose and ketose. Aldose and ketose. Aldose and ketose. Under aldose, it is of glucose, and under ketose, it is of fructose. Monosaccharide. Aldose and ketose. Aldose and ketose. Aldose and ketose. Aldose and ketose. Aldose is of glucose and ketose is of cellulose. Aldose is of glucose and ketose is of fructose. Aldose is of glucose and ketose is of fructose. Oligosaccharide, di, tri, tetra. Oligosaccharide is of three types: di, tri, and tetra. Di, tri, and tetra. Sucrose, refined, stachyas. Sucrose, refined, stachyas. Sucrose, refined, stachyas. Sucrose, refined, and stachyas. And under polysaccharide, it is of again two types: starch and cellulose. Starch and cellulose. Starch and cellulose. Carbs is of two types: sugar and non-sugar. These are sweet crystalline solid. Sugar are sweet crystalline solid, and non-sugar are tasteless solid. Sugar is of sweet crystalline solid. They are non-tasteless solid. Soluble in water, non-soluble in water. Soluble in water, non-soluble in water. Example, glucose, fructose. Example, starch and cellulose. Example, starch and cellulose. Example, starch and cellulose. These are sweet crystalline solid. These are sweet crystalline solid soluble in water. These are sweet crystalline solid and they are soluble in water. These are sweet crystalline solid and they are soluble in water. These are sweet crystalline solid and they are soluble in water. These are sweet crystalline solid and they are soluble in water. These are sweet crystalline solid and they are soluble in water. These are tasteless solid and they are insoluble in water. Glucose, fructose, reducing sugar, non-reducing sugar. Alpha hydroxyl aldehyde, ketone, reducing failing solution and tolerance reagent. Reducing failing solution and tolerance reagent. Reduce failing solution and tolerance reagent. Reduce failing solution and tolerance reagent. Non-reducing sugar cannot reduce swelling and tolerance reagent. Cannot reduce swelling and tolerance reagent. Glucose and fructose. HCO, HCOH, OHCH. Ribose, maltose, galactose, 2-deoxyribose, fructose, lactose, 2-deoxy Preparation of cane sugar. Preparation of cane sugar. Cease with maltose, sucrose, and lactose will give glucose, fructose, galactose. Maltose, sucrose, lactose will give glucose, fructose, galactose. Maltose, sucrose, lactose will give glucose, fructose, galactose. Glycosidic linkage. Linkage of the bond formed by two molecules of glucose in which carbon of one glucose molecule and carbon number 4 of another glucose molecule bonded through oxygen atom by losing one molecule of water. Linkage of the bond formed by two molecules of glucose in which carbon of one glucose molecule and carbon number 4 of another glucose molecule bonded through oxygen atom by losing one molecule of water. Reducing sugar. Non-reducing sugar. Reducing sugar. Maltose, lactose, aldose. Non-reducing sugar. Sucrose, ketose. Amino acid are organic compound containing both amino and carboxylic group. A dipolar ion produced by amino acid is called beta ion. A dipolar ion in beta ion, NS3 is acidic and rest is basic. In beta ion, NS3 is acidic and rest is basic. In beta ion, NS3 is acid and rest is basic. In beta ion, NS3 is acid and rest is basic. Isoelectric point. Isoelectric point. The pH at which there is no net migration. The pH at which there is no net migration of amino acid molecules toward any electrode is called isoelectric point of the amino acid. The pH at which there is no net migration of amino acid molecules towards any electrode is called isoelectric point of the amino acid is called the isoelectric point of the amino acid. Peptide and polypeptide, the condensation product of self-amines formed by the reaction of two or more amino acid molecules are called peptide. The condensation product of self-amine formed by the reaction of two or more amino acid molecules by the reaction of two or more amino acid molecules are called peptides. Keratin in skin, hair, and nails. Keratin in skin, hair, and nails, and feathers. All enzyme, hemoglobin, insulin, albumin, protein. Protein. Denaturation of protein process after which protein loses its physical activity and certain other properties. Denaturation can happen by boiling action of bacteria, shaking with alcohol, treatment with conch acid, coagulation of egg white, on heating coagulation of milk in presence of acid enzyme protein which act as catalysts in many biochemical reactions. These are globular protein which act as catalysts, enzyme. These are very specific in their action. 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 By enzyme activity is very specific. Globular protein possesses particular shape and size for catalytic site. Globular protein possesses shape and size for catalytic site of reaction. Size of enzyme to the reaction for specific activity. Size of enzyme of the reaction for specific activity. Size of enzyme of 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 specific of bases derived from purine and adenine, guanine, pyrimidines are thymine and cytosine. Bases derived from purine, bases derived from purine and adenine, guanine. Bases derived from pyrimidine are thymine and cytosine. Xerophthalmia, night blindness, it is of vitamin A, beriberi, B1, thiamine, telegra, B complex, PB. Pernicious anemia is of vitamin 12 and scurvy is of vitamin C, rickets, vitamin D, hemorrhage, vitamin K. Nucleic acid, long chain of polymers present in high conc in nucleus of cell in which the monomeric unit are bases derived from purine and pyrimidine are uracil in DNA, AGCT, uracil in DNA, AGCT is present, and in RNA, AGCU is present. AGCT is present, and in RNA, AGCU is present. In DNA, AGCT is present, and in RNA, AGCU is present. In DNA, AGCT 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 is present, and in RNA, AGCU is present. In DNA, AGCT is present, and in RNA, AGCU is present. In DNA, AGCT is present, and in RNA, AGCU is present. In DNA, AGCT is present, and in RNA, AGCU is present. Beriberi is of B1, Pellegra is of B complex, PP Pellegra is of PP, and beriberi is of B complex. Scurvy is of vitamin C, rickets is of vitamin D, hemorrhage is of vitamin K. Nucleic acid, long chain of polymer present in high concentrated in nucleus of cells in which the monomeric unit are nucleotides, nucleoside, phosphate, and nucleotide. Bases derived from purine, uracil in DNA, and in RNA AGCT AGCQ present. So yeah, let's take a break. So yeah, guys, let's take a small break and then we will continue with our studies.